An object moves along a trajectory given by the vector-valued function r of t with components 25 cosine 2t, 25 sine 2t. For t greater than or equal to 0, less than or equal to pi. And we're asked here, how far does the object move? So how far does it move? We're looking for the length of this curve. Right, so we recall that the length is defined by the integral from a to b of the magnitude of the tangent vector with respect to t. Right, so this is the integral, again, from a to b, and we could think of this as the distance formula. So it's the derivative of the f component squared plus the derivative of our g component squared, here because we're working in 2 dimensions. So while we have slightly different vocabulary, a trajectory is simply the path an object follows, or a curve. And so we want to find the length of this curve. So the first thing we need to do is find the magnitude of our tangent vector. So differentiating, we are left with minus 50 sine of 2t, and then we have positive 50 cosine of 2t. And to simplify our calculations, let's go ahead and factor out the greatest common factor, 50. So we have 50 times the vector minus sine of 2t, positive cosine of 2t. And so we use this to find the magnitude. So the magnitude of the tangent vector is equal to 50 multiplied by the square root of minus sine of 2t squared. So you end up with sine of 2t squared plus cosine of 2t squared. And we're excited because we recognize Pythagorean's theorem here. We know that that simplifies to 1. So we have 50 times the square root of 1, or simply 50. And so we are now ready to go ahead and evaluate. So keep in mind here that these bounds are our a and b values. So giving ourselves a little more room, we have the integral from 0 to pi of the magnitude of our tangent vector, which is 50 dt, and we're ready to integrate. So this is 50t, and we're evaluating now from 0 to pi. So we have 50 multiplied by pi minus 0, which leaves us with a beautiful final answer of 50 pi. So therefore, this object moves 50 pi units. And that is our beautiful final answer.